Hello everyone. This is a set of instructions to help walk you through one of your big projects, which is the identification of two different unknown bacteria. This set of instructions goes with the virtual approach to this project. If we were in the regular lab, then you would be given a test tube with two different bacteria in it. You'd then perform a variety of tests on those bacteria. You'd look at their test results. And then you'd go to the test results of known bacteria and figure out what your unknowns are based on the results you got in the lab. But here we're going to do a reversed approach since we're doing it virtually. So you're going to go to the Google Docs listed and you're going to sign up for a pair of bacteria. So you're actually going to start with knowing your bacteria. It is not going to be an unknown. It is going to be a known. Okay. And then you are going to look at all of the possibilities listed, and you are going to figure out the pathway that one would take if you start with, 8 possible gram-negative bacteria, and you know yours. How do you eliminate all of the other options using data? Okay, so you're going to complete a set of data sheets that are kind of the imaginary data sheets. If you use on your unknown, on your bacteria, if you perform these tests, what results would you get? You're going to create a flow chart for your gram-negative and a flow chart for your gram-positive, showing me the process that you use to eliminate all the other options. And then you're going to write a couple of paragraphs to defend your process of elimination. So let me walk you through this a little bit. So starting on page 2, you bump into the unknown data sheets. So there's a set for gram-negative and another for gram-positive. And this is the place where you would write out your test results. So you're not going to have to do every test for every organism out there. These are generic test sheets, data sheets, to cover every different test that anyone in the class might need. If you didn't need a particular test for your process of elimination, then you'll just write NA next to that test for the blanks here. You should be able to fill in the first part, which is that test differential or selective? But when it comes to the observations and the keying out of the results, you'll just write NA if that set of data was not needed for the process of elimination. So how do you know what data is needed? Well, after the data sheets, you're going to get into a bunch of tables. So these are the known results for these different organisms. So for example, when you look at the Google Doc with the bacteria listed, you'll pick your pair. Some of those gram-positives are catalase positive staphs. And so here is a table with data for 4 different catalase positive staphs. And say you pick Staphylococcus saprophyticus. That is your gram-positive unknown. And so you're going to have to show me through process of elimination how you started with 8 possible gram-positives and end up with your 1. Well, catalase is a great place to start with yours because yours is catalase positive. And if you look, streptococci are catalase negative. I actually tell you that. So that's a great separator. So you know your unknown. If I look at my data table about Staph saprophyticus, I know it is catalase positive. So the catalase is a great starting test for that. So yours would be catalase positive. So you would fill out the data sheet above for catalase and say, is it selective or differential? You'll have to, do that research and think about it. And then if yours is supposed to be positive, you would say what that positive would look like and how you would key out that result. Okay, so you have figured out that yours is catalase positive, and you look at these other 3, there are 4 on this list of our possible unknowns, and how you say, okay, how do I separate my saprophyticus versus the others on this table? So you can see one good example for that here might be MSA. So you can see that 2 of them are yellow and 2 of them are pink. So that would help separate yours. Yours is a yellow one, so you know it's not epidermidis or luteus. It's got to be one of those two, and say, okay, you've got it eliminated from 8 possible gram-positives down to 2, aureus and saprophyticus. So how would you separate those? Well, it looks like coagulase is different, but if you go and look at our data tables, coagulase isn't listed on there, our data sheets, but novabiocin, the disc sensitivity, just like Kirby Bauer, that is listed. Saprophyticus is resistant, and aureus is sensitive. So if this were an unknown bacteria in the lab, I would say, okay, the first thing you do is a gram reaction. You find out yours is gram-positive staph. The next thing you would do would be catalase, and see yours is catalase positive, thus eliminating all of the catalase negative streptococci. And then I'll grow it on MSA and find out that mine is yellow. So, and what that means, how to key that out. And then I would do a chemical sensitivity test with the novabiocin antibiotic disc and see if mine's resistant or sensitive. And that would eliminate all of the options and get me down to just saprophyticus. So the flow chart that you would design would start with gram reaction. You're going to do a gram-positive flow chart, so you'll need to list all of the gram-positives on our possibles list. And then you would go to the next step, which in this case we said catalase, so catalase positive versus catalase negative. And then the next thing would be MSA results and then novabiocin sensitivity results. So what does that flow chart look like? Well, it's just really simple. And this is kind of a generic one that I created, but here I start with gram reaction. Gram positive, and you list out all the options. Gram negative, and you list out all the options. And then of all the ones that have the matching gram reaction, what's the next test that helps separate? Well, the example that we just went through was actually a gram positive, and the next test would be catalase. So you'd say catalase positive and list out all the catalase positives, and you'd say catalase negative and list all the catalase negative, and yours was positive, so you'd go down to that next layer, and then say, okay, MSA, Y versus R, and list all the options, and you keep going through those layers until you get to your bacteria, your one layer, your one identification. So if your flow chart, you stop and you've still got multiple bacteria listed there and you go, okay, there's mine. Well, the idea of the flow chart is that I can look at it and see exactly how you eliminated all of the other options. So if there's more than one bacteria at that level and you just say, here's my answer, it's bacteria number 4, there it is. Well, I can't tell how you separated 3 versus 4 there. You need to keep moving until I can see, oh, okay, so you did this test and yours was negative, and so there's your answer. So that's exactly, you'll have a flow chart of your gram positive, you'll have a flow chart of your gram negative. So you don't actually need to start with gram reaction on yours. I tell you it's gram positive, I tell you the catalase results, and I tell you the lactose fermentation results. So I kind of give you the first layer for both your gram positive and gram negative to get it going. And then you're going to go back to your tables and start looking for unique things that might help you separate it, okay? So you've got a table for the catalase positive cocci, the staph. You've got a table for catalase negative cocci, the streps. And no, not all of these are your options. Go and look at the Google Doc. There's only 4 different catalase negative options. They just happen to be found on this much larger chart. And then for your gram negatives, we've got a lactose fermenter chart, and we've got a lactose non-fermenter chart, okay? So no, you don't need to do all of these tests. They are not options. If you're feeling a little overwhelmed looking at this, for example, one kind of hint is to go back up to the data sheet and say, okay, so for my gram negative, what are the test options here? So I have MAC results, and what does MAC tell me? Well, MAC tells me lactose fermentation, so that's important. I've got the option of looking at the TSI results, the SIM, MRVP citrate, the decarboxylation tests, and the urea. I've given you a huge hint as to which ones to focus on to help you separate your possibilities, okay? So you will create that flow chart. It can be in the computer, it can be handwritten, and you can take pictures. You will do a flow chart of your gram negative and a separate flow chart of your gram positive. So you'll have 2 separate flow charts. I don't care You know, if you want to do it online and pen, paper, I don't care as long as I can find the data. If you want to take a picture of it and upload it into the document, that's great. Or if you're not comfortable with that, then you can just upload it as a file when you submit this into the Blackboard assignment for this. Okay. And then the other thing you're going to do is write just a couple of paragraphs defending your choices. How, you know, I've got this visual, but then I want you to just kind of put it in writing so you can practice writing your micro here. Okay, so the most important part of the writing is for you to show me the logic of your choices. Okay, so in this case, you're not having to make an identification. I'm giving you the identification. So the significant part of the writing, I'm not worried about you know, the grammatical part of it as much as I'm worried about the deductive reasoning, the logic that you're using to support your choices. Okay, this should not require you having to do a lot of internet search. Like, all of that should be right here in front of you. If I tell you it's a lactose non-fermenter, then what would that look like if you kind of close your eyes and imagine a MAC plate in front of you with that organism on it? I tell you it's a non-fermenter. So what color would that organism be? You know, you don't have to get into great details of, you know, it would be this, you know, the colony morphology and all of that. I'm not worried about whether it's convex. I'm worried about the color for this particular test, right? Okay, and for catalase, did it bubble or not bubble? That's what I'm looking for when I say observations. In the lab, what would it look like in that particular test? Okay, what color is it? Is it cloudy or whatever is relevant for that test? And then key it out. Of course, remember, keying it out means the proper way to write it. Sometimes that's a positive or negative, sometimes it's not. So this project is worth a significant amount of points because it's really kind of the summary of the logic of identification for a lab, a micro lab. Unfortunately, you're not getting to do it, but the thought process is there, and that's really, really critical that you kind of get that thought process of identification and logic and using the known data out there to help you figure out your unknown. So that's the point of this exercise, okay? If you have any questions, as always, feel free to email me, but hopefully our little explanation here helps. Good luck.